Well, hello. Thanks for joining. Just thought I'd get a few things off my chest here. Welcome on an early Monday morning, late Saturday evening, Sunday, pardon me. Might have somebody stopping by, not sure yet. Just figured I'd start up a hangout and talk about a few things. There's a bunch of things going on, and some folks need not be sidetracked by everything else that is going on. I know we all have things going on in our life. Pardon me. Really simple things. Okay, so I recently saw a video which actually had an excuse. I'm just going to use a green marker for this. Somebody was at the shoreline. Oops. Shoreline. There we go. And had a tripod with a camera fixed, fixed position camera. Of course, we've all done this before. And you're looking over the water this way. And whatever the height is, that will be determined by, the base to the top of the camera. The problem with this is in building, what's happened over the years is when you're using a transit, which is very similar. It's what's called a tripod, 3 legs. Normally, it's some sort of optical device. Can be many different things. They use digital now, laser. When you look through this, okay, and this is a person. Okay, now looking through this, if this particular optical device goes up or down, let's say, let's be real simple here. Let's use something very simple. Let's say 1/8 of an inch. Okay, well, 1/8 of an inch. Well, if I have a level plane, drawing it as simply as I can, and this is our person here with the tripod looking through, and it has a fluctuation of 1/8 of an inch. Well, does that make a difference? Well, it really does. It makes a difference because if it's 1/8 of an inch lower, eventually they splash down. 1/8 of an inch higher, of course, they're shooting out here into an aerospace or somewhere out here, possibly an airplane. It's very difficult to create a point which would be X to go to Y and be absolutely straight. The slightest variation in it could be just the observer. It could be anything. It could be the equipment itself, which would actually anybody who's been hunting, and I know some don't like hunting, some don't like people that hunt. If your shot is off by an inch, you go home empty. This sort of thing, proving anything one way or the other, is kind of silly because just by you tapping this, and again, as a builder, if you have a tripod set up right here, tripod set up, or a tripod transit. Okay, well, any tapping of this will offset the visual from here to here to here. It's very difficult to get this totally what they would call plumb or level, and do an experiment based on this. Optical vision is one of the best things that we do have, and we still have, thank goodness, because we are able to see over a great distance and be able to tell, okay, is this correct or is this not correct? A very simple thing would be binoculars. As a fixed point, being this as a fixed point, this could vary based on the equipment that is being used. And I saw a video recently which used something similar to this, and zoomed in, zoomed out, zoomed in, zoomed out. Every time you zoom in and zoom out, you're actually touching this device right here and obscuring the vision of that device. Now, it might seem not seem like much at this point because you're right here. However, over a distance, it's going to vary greatly to this point and this point. If you can still see that, it's like a pizza wedge, if you will. It's going to vary quite a bit. You can't conclude anything by just doing this particular thing, zooming in, zooming out, and saying it's A or B, and coming to that conclusion. There are too many variables in that. Why did I go to the whiteboard, do you ask? Because things are getting silly. They're getting silly in a way that everybody is becoming an astronomer, which certain people have not only degrees, but have studied this sort of thing for an awful long time. You can't really refute what these people know or have studied because they've been doing it for so long. Several friends of mine have done this for a long time, and they will actually go back to and say, yes, but have you checked out this, or have you looked into that? There are certain things that I know, certain things that different people know. One is that you cannot possibly just measure from one specific spot and just hold that true unless it absolutely is true and never touched. That will give you that true line straight across. Of course, forgive me because it's a little wobbly. That is one true line, which if this is not touched, correct. If you touch this or try to zoom in or obstruct this unit in any way, shape, or form, it's going to move up or down, giving you this type of trajectory, either down or up. It's not going to make any sense. Whenever somebody is, that's why everyone has gone to laser transit as of late. Get rid of this. Okay, the laser transit is basically a laser head with our all-seeing eye, of course. We love that so much. And this goes around in a circular motion like this, okay? And subject A stands here with his stick in his hand like this. And what happens is the laser shoots across, very true. And if the top to bottom measurement here is 3 feet, right here will also be 3 feet. Excuse me, 3 feet. Because nothing has touched this right here. Nothing whatsoever. Therefore, by not touching this, that will give you a true measurement across a vast distance or a greater distance. Think of it this way. If somebody were to build, let's see, somebody were to build a stadium. coliseum, if you will, something like this. You got the parking lot down here. Here's the inside of the stadium, like this. Okay. Now, from this side to this side, how big is the stadium? Well, let's see. Depending on the stadium, you have 100 plus yards inside. You're going to have seating, which you're going to want to go like this. Okay, on both sides, of course. So you're going to have, let's say, another 100 yards. So that's 3 and 3. That's 600. 600 feet from end to end. Plus, you're going to have beverage and so forth on the outside. You're going to have facilities on the outside, which are going to go this way, like this. Okay, you're going to keep going and going and going until finally, let's see. The average stadium, I don't have to Google it. I can just sit here and guess. It's going to be, let's say 2,000 feet. 2,000 feet from end to end. Okay. Now, you got 8 inches per mile squared inches. There we go. That is the curve. The curve at 24,901 miles in circumference. Okay. So by taking that into consideration, a mile is 5,280 feet, right? So this is almost a half mile. Okay, now real simple. We're going to take our same little gentleman, and I think I can put this over here. I might not be able to see it. So let's make a little incision right in here. And here is our little guy. Here's our little guy with his laser seeing eye. Okay, and here's our second person way over here who's actually holding that stick for a survey that is done all the way across the stadium. And again, 3 foot off the base and 3 foot from the finishing point. Now, based on curvature, which I know what this means, many don't, you're going from point X, okay, here, over to point Y. This is not quite a half mile. It would be approximately 4 inches. So being 3 foot is 36 inches on this side. It should be approximately 39, which is kind of funny because that's actually a meter. On this side, it should actually be higher on this side. If anyone can show me definitive proof, plans, CAD system, anything else that shows anybody who has built a stadium anywhere across this approximate distance actually calculated for any type of curve. Now, I know what you're going to say. It's on flat land. Okay. It's on flat land. Based on this calculation as well, the average level, builder's level, is 4 feet. Okay, in the center, they have what's called a bubble. Okay, now when you build something, they say, where is the bubble? How close is the bubble? Anyone who's been in building knows this term very well. The bubble is a quarter off plumb, which would mean the bubble is heading downward in this direction, a quarter inch per foot. Okay, that gives you water runoff. And I would digress to a political hillbilly who would also agree with me and probably add several things to this. He's not around at the moment, so I'm going to go ahead and go about this myself. It's actually bubbling down, meaning that the water will drain down to one side or drain up to one side. Now, using a stadium, I'm using the structure. Don't get me wrong, I'm not using the actual turf playing field. I'm using the structure as being very far from side to side or from end to end, if you will, depending on if it's circular, octagonal. It doesn't matter. Pick a shape. From one end to the other, this is sort of the dimension that I'm using, which would mean that one end would have to be lower than the other. It doesn't happen. It doesn't happen in building. Okay. This is what actually happens, and it is not 39 inches. It's actually straight across the entire distance. You could, once again, you could say, okay, they built the land up on this side to match it, to do something else. Okay, well, if that's the case, let's go back to the bubble. The bubble is in water. It's water with air, and it is very, whoops, I'm sorry about that. It's very simply done, where you have a bubble in air. It's an air bubble in liquid. And what happens is the bubble has, if you look at it closely, it's like this, okay, and has hash marks. And typically, there's your bubble right there. Now, if you're going to be off a certain direction, the bubble will move from there to here. And that will give you a fall, meaning this side is higher than this side is lower. It's real simple. You go back to the simple basics of looking at a 4-foot level or a bubble to try to get the water to move one side or the other. Water will always seek its own level. By this alone, this definition alone, there is no bendy water. It cannot bend. It would bend right here. This is the lowest simple common denominator that water will bend. Doesn't bend. Doesn't happen. So please stop with, I'm standing, excuse me, let me erase this. Please stop with, I'm standing here and I have this camera like this, looking at water, and then I physically touch the camera and zoom in or zoom out. And all of a sudden, the water rises, then it comes down, then it rises, then it comes down. Please. It doesn't work like that. By definition of what you're doing, you're obstructing the unit of measure right here. And you are now creating a stadium that looks like what we saw in the 70s. By the way, Bill Cosby got a shitty end of the stick there. This was how we saw the 70s, if you recall, with all the buildings and the Cosby Show, Fat Albert and the Cosby Show. Everything was wider at the top. That's how it would work. It would work that way on a ball. If you had a ball like this, the buildings would be engineered to what they call gravity. or big G? Well, structurally, the load would be down like this. So the top would have to be wider than the bottom. Small, large, in order for this to work properly and for the correct amount of pressure to be applied downward, the top would have to be larger than the bottom. It's very simple. It's not only real simple, it's very self-evident. Anybody out there with a transit, please take heed and take a little, take a look. Got to be careful how you do these kinds of experiments, because it might not be exactly how you want it to turn out. It shouldn't turn out any way but the truth. And the truth is, it doesn't work like this. It's not wider at the top and smaller at the bottom. And this is Earth with gravity, because by the definition of load coming down, this is how it would work. It would have to be larger at the top than the bottom. Going back to a stadium effect, we all love our stadiums. Your team here. Excuse me there. Your team here. Okay. So what you're saying is, instead of what you're seeing there, that's what you're saying. That's what they're saying. This being a stadium, that the top is large and the bottom is smaller. That's what they're trying to tell you. And that's based on the very common denominator of, you think you're on a ball, you're not in a ball. It doesn't work that way. Now, as far as where we are, when we are, how we are, I do not exactly know. I know we got somebody out there in chat. Surprised we have somebody out there. Give us a free water dynamics inside the cylinder. Let's make this official. Water dynamics inside a cylinder. As far as fluid is concerned, well, fluid, oh man, fluid as far as dynamics, I mean, come on, because you take a regular glass, okay, go ahead. Regular glass, like that, okay? And if you fill that glass with water, okay, it's going to have that little bit of overture over the top before it actually spills over. It's going to have that little bubble, if you will, over the top. And this glass is going to be totally level across the top here. It's going to have that little bubble right across the top. So you tell me, why is that bubble right across the top there? Does it have to do with gravity, or the fact that you filled it too much and the water says, uh-oh, I got nowhere to go? It goes up to a point and spills. No, that comes back to that bubble effect that I told you about. Remember the bubble? Remember the level? Remember the level? Very simple. Level. Well, it has to go above level, especially in capacity. Oh, I can't. Hold on. That's going to come out really blurry. Sorry about that. Capacity to go up to overflow the sides. Well, guess what? If the capacity is going up like this, guess what? It's going to overflow the sides. It's the same damn thing. Any mental midget can figure this out. I'm not the sharpest knife in the drawer. Trust me. I can figure this out. You guys should be able to figure this out. It's very simple. Everybody's arguing and they're back and forth arguing about, okay, well, show me this. Well, show me that. Okay, well, go ahead. Show me. Show me. I don't need to debunk anything. I will listen. I will look. I will do my own experiment and take a look at it. Waiting for somebody to chat. Oh, I see Jaybirds out there. And if I could pronounce your name, I definitely would. I cannot. Wow. I'm just going to call you D, if that's okay. D is out there. D chatted in there. That was the about the fluid capacity. Can't even begin to say that name. Excuse me, I had to let some water go myself. Okay, so moving back. Let's take this once again. So you have somebody here who has a tripod setup with a very nice camera. Okay. Shooting over here. Okay, now, once that person touches this, it's going to obscure no matter what. Let's say it's zoom. Focus. Whatever you're doing. If you touch this, it negates what you're doing. You have now altered this position, and you're going to get this result. Here, 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 here. It's not going to be your true result. Once you alter this particular mechanism of measurement, it's not going anywhere. It's going all over the place to the point where you cannot possibly call this, okay, yeah, this is a, I can't even draw a thumbs up. A thumbs up. That's a thumbs down. Can't do it that way. It doesn't work. So if someone would like to present a test like this, done correctly, that would be wonderful. Where you would have a stationary camera, which we have had people do this before. I don't know why we're going over this so many times again. They set it up, and then what happens? The person or the observer walks away, getting rid of the observer, letting the instrument speak for itself. And bringing that particular ship right back into focus. Real simple. It's just very simple. Nobody gets this, and they keep arguing. It's like, oh yeah, well, I was here and I made 14 adjustments to this over here, and all of a sudden it went down, it went up, it went back, it went forth. Now, real simple. Set this up. Don't touch it. Here, This is what moves up and down, left or right, whatever's going on over here. Presenting this 3 foot here and here over the distance of X. That's what makes a difference right there, because presenting this over a span of X, which from what I have seen, is 3 to 5 miles. Okay. You can't possibly see most any of this. In fact, you would probably see that. And we don't. As crude as it looks, my little boat with the little captain on it. Here's his wheel. Captain Bly. Captain Flat Earth. Is right there. Until next time, guys, I will see you soon. Start another broadcast pretty soon. See if I can get some friends to join. We'll see what happens. We'll go over to Dome, which is also something else. A little preview for anybody who's watching or going to watch us. I did this in a video a long time ago. Basically, you have, and I don't want to dispute land mass or continents or any amount of continents. This is land. And yes, Jibby, this is the toilet bowl model. You have the firmament over the top. However, there are many layers to that firmament. Okay. Not sure how many. I've never been up that far. Let's say, for instance, that's the moon. The moon's on the inside. Okay, let's say there's water in between. And let's say the sun is out here. Pardon me, sun. Sun is out here. You can change these up any way you like to. You can say sun, water, moon. Maybe there's water once again. I don't know. There are different things happening here which we do not know. Some people may know. It's just that we will not know. So stay tuned. Be good. Be flat. I'll be back.